Now, this is going to be a different type of video, actually, and it's going to use artificial intelligence in a sensible way. Now, I generally resisted artificial intelligence because the little experience I had of it, it's just reflecting the biases and everything else of what's out there. It's like a super Google, if you like. But I watched a program on a Tom Nelson podcast. I'm going to give the link to that below this video. And it's about Willie Soon and people and a friend, another scientist, actually writing a paper using Elon Musk's Grok 3 beta. That's what it's called, GROK 3 beta. And I accessed it. I'm a member of X, so I think I get on anyway. But I accessed it and started playing with it. And I had conversations with it, and I was pointing out things like, you can't say that because that's consensus. There's no place for that in science. And it would agree with me and inspect that, and gives you all the logic of what it's doing all the time. And I realised it could be a very valuable assistant. So I thought I'd give it a test, because it's like having a free personal assistant who'll go away and investigate all the papers, then ask you, what about that? And you'll say, no, have you considered this? Or look at this paper. And it'll carry on. So it's a very interactive thing. So I decided to take a simple test. And something that annoys me, I've actually dealt with it on air on GB News with Nana Rakua and Jim Dale, where people have mentioned to me the record temperature, 40.2 in Heathrow. Remember that in 2022, I think it was, 40.2 degrees. Well, that's an urban heat island. So the question arises, well, why don't you allow for the urban heat island? And the answer is they don't. And then you look at other factors such as the Met. You find out what sort of who measured it. You find out it's the Met Office, and then you ask, is it aspirated reading, a temperature reading? And no, it isn't. So it's not ventilated. So when it's below 1 meter a second, wind passing through the Stevenson screen, it starts to overread. And when's it going to overread most? On a hot, baking hot day, clear sky, record sort of temperatures, it's going to really overread, isn't it? The box is going to get hot inside. And so how much would it overread? And so I started asking Grok 3 these things, and I've come up with a very interesting result on what the real temperature would be like, because there was another temperature gauge near it, and that is the temperature gauge from the airport itself, which is aspirated, which means that it is ventilated, and so it doesn't suffer from that. But of course, it still suffers from the urban heat island effect. And how much can we reasonably say that is? I mean, at times in London, it can be up to 10 degrees at night, and it's a bigger effect at night, which changes the mean temperature terrifically. And don't forget, daily temperatures are the maximum and the minimum halved. So if you lower the lower part, so with this simple thing, here we go. Look at my experience with Grok and look at the amazing answer. Grok and I working together by me referring things back to it and questioning it comes up with for what the real temperature should be, not the 40.2, I can tell you. So here goes. So I first queried Grok on, well, when the Met Office adjust all the temperatures in a process called homogenization, which I really think is a fiddle, or do they even consider this ISO standard, which says you must have 1 meter a second of air through to not overread a temperature? And the answer came back here. This is the conclusion. In general, homogenization for climate records does not explicitly allow for or correct for the lack of wind below 1 meter a second in Stevenson screens. I won't bore you with the rest, but it goes on to say the standard methods focus on the larger, more detectable things, station moves or instrument changes, and treat the wind-related bias as a minor source of measurement uncertainty. This bias is typically small, variable, and assumed to average out over time to be consistent across stations. This is not significantly distorting long-term climate trends. But I'm here not asking about that, and that's quite interesting. So they don't take it into account in the calculations to correct for it at all. And of course, Grok is wrong in saying that it'll balance out over time, because this particular aspect of lack of ventilation through the box will only ever overread. It won't underread, so there is no balancing out. So I challenge Grok. Still staying in the same subject, I come back with, by how much can temperatures be out inside a Stephenson screen when the wind is below the ISO specified amount of 1 metre a second? On hot windless summer days in the UK, say. So that's the question, and here's where it came back with. Research, including comparisons between Stephenson screen readings and aspirated thermometers, that's ventilated ones, which provide a more accurate baseline, suggests that in low wind conditions on sunny days, the temperature inside the screen can be 0.5 C to 1 degree C higher than the actual air temperature. And in extreme cases with intense sunlight and completely still air, the error might approach 2 degrees centigrade. But for a typical UK summer day, where solar radiation is less intense than in tropical regions, the error is usually lower. Considering the query's focus on hot windless summer days in the UK and the ISO threshold of 1 metre a second, the most reasonable estimate for the maximum temperature deviation based on standard Stephenson screen performance in UK condition is 1 degree C. This value aligns with practical meteorological guidelines and accounts for the screen's design mitigating larger errors. Thus, the temperature inside a Stephenson screen can be out by up to 1 degree C under the specified conditions. So there we've got it. We've got a 1 degree C error at the Heathrow temperature gauge, providing we're reading the right one. Now, at this point, by asking more questions of this marvellous research assistant, I was able to establish 2 thermometer readings, 2 stations at Heathrow, one owned by the airport and one owned by the Met Office. So the question was, were they aspirated? And here's the answer. Well, Heathrow Airport uses a weather station from Thales, which provides aviation weather systems with a fan-aspirated temperature sensors. So it seems the temperature gauge at Heathrow Airport is aspirated based on Thales product details. And no problem with that. So the airport one gives a much more correct reading, doesn't have this error because it always is ventilated. But the Met Office one? No, that is not aspirated, is not ventilated, so it does have this error, but then it's there for a different purpose, to measure sort of trends in temperature, not particular individual readings like record temperatures. So in their headline chasing way, nothing to do with science, the Met Office claimed record temperatures at Heathrow. Let's read it. The Met Office recorded 40.2 degrees temperature at Heathrow Airport weather station, specifically the one with station identifier 03772. That's critical because that enabled me to find out which one of the 2 it was, and it was the Met Office one, not the airport one. This station is located near the northern runway of Heathrow Airport in London. The record-breaking temperature was previously recorded in July the 1922, 12:50, marking the first time the UK exceeded 40 degrees centigrade. A lot of alarm there, and the BBC, of course, follows up with a unique one. This record temperature causes it to select individual houses between other houses and burn them down. Look at this. And for the record, here in Britain, we are forced to pay a fee every year, £170 to keep the BBC going like a tax. And they put out absolute rubbish like this all the time. They're a propaganda organisation, not a broadcaster. Now, many years ago, I used to be in charge of meteorological stations, whole networks of them. And I know that if someone came to me and said something, a junior came to me and said this and that, I would question them. And in just the same way, I'm questioning the Met Office now on this record temperature you've just seen claimed, because we've already established on just one factor alone, it can be a whole degree out. But they're so confident, they're quoting to 0.1 of a degree. But there's more. And it's the urban heat island effect. All the concrete, the runways, the bitumen, the buildings, the airplanes, etc., will create an urban heat island where it'll be hotter there than it would be in the surrounding countryside. So we have to allow for that. So we start chatting with Grok to put that into the equation. Now, when I first questioned Grok about urban heat island Heathrow, he gave me general wishy-washy stuff and said, yeah, there will be some, bang, bang, much bigger in London, of course, in central London. I agree. But it didn't give me the details, so I had to question it and say, well, dig further into this. Look at research papers. Let's try and agree on what the urban heat island effect would be. So look at what it came up with. It first of all agreed with the general idea that there must be an urban heat island effect at Heathrow Airport. And it said this: the overall effect. The urban heat island effect alters temperature at Heathrow Airport by elevating both minimum and maximum temperatures compared to what they would be without urban development. Now, that, of course, would affect the long-term trends as well, because it raises the average temperature you're reading. And don't forget, daily temperatures are max and min divided by 2, just average. The most noticeable impact is on nighttime lows, which remain higher due to heat retention, and that, of course, will lift the temperatures in any urban heat island, lift the average temperature, while daytime highs are also increased, albeit potentially to a lesser extent due to the airport's unique layout. This results in a warmer microclimate at Heathrow consistent with its position within London's urban heat island. So it's saying, yeah, it's within London urban heat island. There are other factors to take into account, but I had to dig further. Well, after a lot of pushing Grok to look at research papers around the world and try to reach an actual figure for the urban heat island effect at Heathrow, it came to this conclusion. The urban heat island effect alters temperatures at Heathrow Airport by approximately 1 to 3 degrees Celsius during the day and 2 to 5 degrees Celsius at night, compared to nearby rural areas. These estimates reflect average conditions and may vary depending on factors like weather patterns, with stronger effects during heat waves. Well, of course, it was a heat wave at the time, so it'd even be stronger maybe. Or calm nights and weaker effects on windy or cloudy days. Whilst precise measurements specific to Heathrow would refine these figures, this range aligns with broader research on urban heat islands in London and similar urban airport settings. Well, so what we can take away from that is, by the way, the average temperatures will be way out because of the urban heat island by many degrees. But the peak temperatures, what we're looking at here, can be 1 to 3 degrees out. Now, one of the things that really annoys me about so-called climate scientists, there's no such thing really as climate scientists, multidisciplines, many from geology, statistics, physics, and so on, hydrology, and so on, is they call themselves this pure climate scientist, when in truth they get a PhD about one glacier or one tiny bit of thing, and then specialize in something. So whilst I was researching Grok, I had to take this further because I'm a practical scientist in the sense that I regard myself more as a technologist in applying science, but I have to check it. The problem for me is the science has to work. So when I did my work in forecasting droughts and doing all sorts of things, it has to work in practice because it's put into practice. Just like you put a bridge up, you don't want it to fall down. It's the same principle. So I push Grok on one more thing here. We've got the ventilation out the way now. We've got the urban heat island out the way now. And there's another thing, and it's this. Temperature gauges have changed. You have the thermometer inside the Stevenson screen. That's one way. You can have that with a fan over it, so it's aspirated. Or you can have an electronic one. Now, the dampening of the thermometer means that it doesn't pick up tiny little variations in the temperature, so that you will get different reading for a high temperature on an electronic one than you would, and you even get a lower reading as well on an electronic one because it's reading more instantaneous values rather than the dampened out thermometer. So this has to be allowed for, and there's work being done on this, of course. So the great thing is now I could ask Grok about this and say, hey, you've got so far, but you've forgotten about this effect. So what's this effect as well? And I'm going to show you two answers from Grok as we went through this now. And interestingly enough, some of the stuff comes from Reading University. And of course, Reading is the professor on climatology there who had a run-in with me on air turbulence because I presented the verification. His verification wasn't there. I was able to prove it doesn't work, what he'd said. And so if it doesn't work in the real world, science is dead. But instead of having to go at me or agreeing to debate me or discussing with me, he just went on Facebook and personally attacked me, calling me all sorts of names and so on. So that is typical. I even made a video about it. So with some delight, I didn't know Grok was going to go there. It actually went to Reading University for some of the backup on this. So I'm going to take you through the final stages now of this and end up with a figure of what we think Heathrow actually was on that day. So here goes. Here's the first response from Grok after being pushed on the matter. So this is the first answer from Grok. To quantify this, we can look at nearby rural temperature readings from that day. And for comparison, for instance, Rothamsted in Hertfordshire, about 40 kilometres north, Odderham in Hampshire, 50 kilometres southwest, both rural Met Office stations recorded highs at around 36 to 37, though not necessarily at 12:50 p.m. Heathrow's uncorrected peak of 40.2 at the Met Office, and my aspirated estimate of 39 degrees centigrade, and when I say my Grok's estimate, because of the lack of the aspiration for the airport gauge, suggests a 2 to 3 degree difference from rural areas. Part of this gap is the urban heat island effect compounded by heatwave intensity. Research on UK heat waves, example e.g. from the University of Reading, indicates the urban heat island at Heathrow can add 1.5 C to 2 degrees C on a hot sunny day, depending on the time of day and wind. And given the light winds and peak heating at 12:50 at 2 degrees C UHI, that's the urban heat island contribution, is plausible for Heathrow's airport airfield environment, where tarmac and jet activity exacerbate local warming. Subtracting this from the aspirated gauge estimate, this is what we get. Starting point 39 degrees C, airport gauge corrected for lack of Met Office aspiration, and then the urban heat island adjustment -2, the adjusted temperature then becomes 37 degrees C, not 40.2. This 37 degrees C represents the approximate air temperature at Heathrow Airport without the urban heat island effect, aligning more closely with what a rural gauge in the region might have recorded under the same conditions. A range of 36.5 to 37.5 could account for the variability in UHI strength, 1.5 to 2.5 degrees C, and slight differences in rural baselines. Does this, and it's coming back to me now to ask a question, does this 37 degrees C estimate, stripped of both non-aspirated bias and UHI effect, fit your expectations? Well, it hasn't allowed for using electronic gauges compared to using just thermometers, as it were. So now we've got to allow for that. And I've already explained why there's a difference between the two. So I went back to Grok and said, well, have you allowed for this? Consider this, do the research on this and come back with an adjustment. And it's such time saving. It goes and finds all the relevant papers, looks at the research, balances it, argues with itself, and then comes and gives you the whole argument. Absolutely fantastic saving in time. So here's its final answer. Now let's consider the electronic nature of both gauges. Since both the Met Office and airport gauges were likely electronic PRTs, their readings reflect the same instantaneous time frame, not a like thermometer response. I didn't know that, so it found that out for me. If the Met Office had used a traditional thermometer, its 40.2 C might have been lower at 39.5, just due to that, of course, due to slower adjustment to the peak. But as an electronic sensor, it captured the maximum as it happened. The airport's aspirated PRT similarly instantaneously aligns with the 39C before UHI removal. The adjustment here is minimal because both gauges share the same fast response technology. However, if we assume the airport's aspirated sensor avoided microscale heat spikes, e.g. from tarmac bursts, then the Met Office non-aspirated sensor may have picked up the true air temperature and could dip slightly lower. Let's refine it. So then they say the airport gauge instantaneous aspirated 39C, subtract the UHI 37C, allow 0.2 C for potential electronic oversensitivity to localized peaks at the Met Office site, not fully mitigated by the airport aspiration. This brings us to 36.8 C for the airport gauge, rounded up to 37 C for simplicity, as instantaneous nature of electronic sensors doesn't require a major shift from our prior estimate. The key difference, non-aspirated versus aspirated, has already been factored in, and the electronic response reinforces the precision of that correction. Does this 36.8 to 37 degrees C estimate, accounting for electronic sensors and prior adjustments, work for you, or should I explore further refinements? And I'm happy with that. So what do we end up with here? So there we are. We don't have 40.2, we have 36.8 to 37, that sort of range there, as a reasonably adjusted temperature to allow for the errors they have in recordings, right? All they did, of course, was take the 40.2 reading, end of subject. Let's go to the press, let's make a big story worldwide about the hottest temperature ever in UK. Over 40 degrees. It wasn't even probably, well, it wasn't past 37. So that's how it's fiddled. Now, this video's not just been about the temperature, Heathrow. It's been about the process now of how artificial intelligence can be used. You can't trust its answers straight away. You really have to argue with it, probe it, and you have to know your subject to do that. So if I hadn't known about these other factors, I'd have just accepted that first one. So it's a tool. It is not the be-all and end-all, but it's a fantastic tool because, for example, in the Heathrow thing, it looked in more detail than I knew about. Going to local stations in different directions, trying to get the right temperature that day, etc. I mean, all the Met Office had to do was compare it to the aspirated temperature from the airport to realise a big error of a few degrees. That's all. So if you add all these things together, the aspiration, the ebb and heat island, the fact electronic meters are being used, you also come to realise there can be 0.7 degrees centigrade difference just using an electronic temperature reading compared to the past liquid, mercury thermometer temperature reading because of the light. That would give a much higher temperature to more recent stations than the earlier stations, giving a nice growth to fit the alarmism. In my work, I had to always check any data I used, and you have to look into it. And you can get, especially the young people, although I was only in my 20s when I was in charge in Wales, you have to get people to understand that the world is not just the number you pick; it's the number that you pick that really does it really measure what you're after. And by the way, that 40.2 was debated on GB News on the Nana Akua show. And Jim Dale said, no, they allow for it all. No, they don't. They just read the 40.2 and published it. We got the story worldwide. Hottest. We've passed 40 degrees now in Britain. So I hope this has been an enjoyable exercise for you to watch how artificial intelligence works and how it has to be used. But without knowledge, it's dangerous to be used as well. So you've got to be very careful and balanced. Well, the homogenization, by the way, afterwards done on all the figures by the Met Office and others, is absolutely just fiddle stuff. And it's not the same as what I've just done, right? Not the same at all. In fact, they've got over 100 stations, Met Office stations, reading temperatures that don't physically exist. They just guess that they're there. They've only got 13.7% of stations, according to the World Meteorological Organization, that can read to within 1 degree C anyway. And yet they're reporting temperature records to 0.1 and 0.2 of a C. It's absurd. Thank you for watching.